testing the V1 Saliency Hypothesis by V1 neural responses to salient inputs in behaving monkeys. Various predictions from ViSH have been tested and confirmed by behavioral and imaging experiments. Now let's show some evidence from V1 neural responses in behaving monkeys. In this study, the monkey is first shown this image in each trial and should fixate the gaze at this location at first. After the fixation is verified, these bars appear. All bars are uniformly oriented except for an orientation singleton. The monkey should quickly find where this singleton is and make a saccade to it as quickly as possible. In each trial, this singleton could appear randomly at one of the 6 possible locations. For example, it could be here in a different quadrant, or a different location in this quadrant of the visual field. To get rewarded by a sip of water for a trial, the monkey must make a direct saccade to the target from the central fixation point. Indirect saccades are not rewarded, and of course, incorrect saccades like this one or this one are also not rewarded, and the monkey is also not rewarded if the saccade takes too long to start. In some trials, the singleton target is in the restive field of the neurons whose activities are being recorded. And since it typically takes at least 200 milliseconds for the monkeys to start the saccade, the neural responses before the saccade can be observed. So we can ask, if a trial evokes a higher V1 response to the target, is it more likely for the monkey to start the saccade more quickly and to aim the saccade more accurately? This is indeed observed. These are the V1 neural responses during the initial 200 milliseconds after the bars appeared. The neural spiking rates are plotted against the time starting from the onset of the bars. The firing rate peaks quickly at around 50 milliseconds and then decays before the saccade starts. The red curve is the average across trials in which the saccades were faster and also aimed correctly. And the blue curve is the average across trials in which the saccades were slower or aimed incorrectly. And this significant difference occurs at a latency of 40 to 50 milliseconds from the appearance of the bars. And this short latency means that these V1 signals cannot come from some feedback from higher brain areas or from the superior colliculus. This response difference is for when the saccade target is tilted 90 degrees from the background bars, so the target is the most salient. And these are responses from neurons whose preferred orientations are more similar to the target's orientation. And we also emphasize that these two response levels in V1 neurons and in monkey behavior are for the same visual input and with the same 90-degree orientation contrast between the target and background bars. When the orientation singleton target is less salient, by having a smaller orientation contrast from the background bars, the initial response difference is smaller when the monkeys were less trained in this task. And of course, their task performance for less salient target was also worse. These V1 neural activities, linked with ongoing saliency behavior of the monkeys, provide a strong support to the V1 saliency hypothesis.